everyone, this is something of a departure in terms of the videos I usually feature on this channel. Obviously, anybody who's followed me for a little bit knows what I use Science First for is simply a platform to put on the research of other people, videos they've produced that they share with the media and with the press very kindly. Just essentially to add a bit of depth to the articles that I write on Medium and for other websites and platforms. What I thought I'd do today, though, is share a little bit of footage from July this year, when I was fortunate enough to be part of a group of journalists and science communicators who were invited not just to visit the Large Hadron Collider at CERN, but to actually go inside the tunnel that houses the Large Hadron Collider. This was possible simply because the collider itself is currently in shutdown mode. So normally, ordinarily, members of the public wouldn't be allowed in there. We were allowed in. As you'll see, going through the double doors, the first thing you see from where we entered from the Alice facility. So there are a number of detectors at CERN, at the Large Hadron Collider. Alice is one of those detectors. CMS, where the Higgs boson was detected, is another one. So we immediately came through, and it was a bit of a thrill for me because one of the first pieces of equipment that we see was provided by Fermilabs. I've always had quite an affection for Fermilabs, simply because a friend of mine who's a professor of physics, Martin Turner, used to work at Fermilabs. So that's one of the first pieces of equipment that you see attached to the Large Hadron Collider. So what you'll see as we move through is you'll see the actual collider itself, where particles are sent hurtling through in order to collide with each other and generate the kind of energy levels that the scientists working at CERN hope will help us distinguish new aspects of physics. Actually seeing there are all these pipes and wires and very intimidating machinery. These are both cooling elements. It's important that the Large Hadron is kept cool, it doesn't generate, and also the power supply to the which directs charged particles around the Large Hadron Collider in order to make them together. What's interesting is if you look at the top of the screen, you can actually see a guide that is it's just there during. So the aim of that is to stop people into the collider. Obviously, me being a big buff, I might trigger the guide wire and get telling off from on day. Now, unfortunately, you can't really hear what the guy's saying. At the end of this video, I will put footage on again, raw and unedited, and then you can listen to what the guys. Obviously, CERN spoke to them absolutely fine with me, the video and what the guide said. So at the end of this video, I'll put this footage on again. So the idea of the high luminosity upgrade, then, as I was explaining before, I described what all these various bits of machinery are for. The upgrade is basically to reach a new energy level, which at the moment the LHC can't reach. So that's the high luminosity upgrade. It's kind of physics at the moment is beyond its reach. Obviously, this is beyond the detection of the Higgs boson, which completed the standard model of particle physics. What they're looking for at CERN now, and what the aim of these high luminosity upgrades are for, is to look for physics beyond the standard model. There are a lot of unexplained questions that were left by the detection of the Higgs boson, such as why does it have the mass it does? because the Higgs field seems to teeter so close to instability that the slightest nudge, one way or another, would have prevented from matter from forming in the universe. It would have prevented electrons from gaining mass. So obviously, with what the high luminosity upgrade will do is that's going to provide the Large Hadron Collider with more collisions, thus more chance of seeing particles maybe we've not detected before, new elements of physics, new mechanisms, and also a higher energy level, because the work that CERN's done so far with the Large Hadron Collider, they've really covered a lot of the energy levels that it can currently work at. So they need to expand it and go beyond this, and that's the aim of this high luminosity upgrade. So I hope you enjoyed this footage. I have got to say the trip was an absolute blast. It was a real thrill to go inside what is one of the most, well, not even one of the most, the most audacious science experiments that humanity's ever undertaken. It's mind-blowing to think of this collider built underneath the mountains of Switzerland and France, and it really shows. There's a message that I took away from it, was look what our nations can do when we work together rather than working against each other, when we work in conjunction with each other. Look what we can achieve. We can probe fundamental physics at such a level that we can really understand how the universe formed, how we're here, and that's only by working together that's achieved. And that's what I really took away from my visit to CERN and Hadron Collider. That was the aspect that I really took away, was how important collaboration is. Okay, I hope you've enjoyed this video, and thank you for listening to me ramble. Is that message now unedited? Hopefully you can maybe pick out a little bit of what the guide said the day. All remains for me to say is thank you for CERN for allowing us all to come and take a look round. What a fan.
Yes. We need bicycles because the machine goes 27 kilometers, and we got 8 access points. So this is meaning that we got 3 kilometers between the access. In this case, we have to work in the middle of the sector. We also have in case we have everything to this one can pull about 75. So this is the head. Okay. So we are in the middle of the machine, and especially here we are in the straight part of the machine. It's perfectly straight. We'll go after it in what we call the arc. Where are the standard lines for gaining the wings. But here we are in the zone where the wings are prepared for the collision. This is meaning that the beams actually they are perfectly aligned. Okay, and also we try to obtain the maximum luminosity. Luminosity is the value. It's the ability of the machine to produce collisions. Okay, so you heard about luminosity. Maybe you have heard about the high luminosity energy, which will be the next evolution of the machine. Okay, so these magnets here are here to here is one. Okay, we will see exactly the point where the beams are
careful of the wire. You almost you touched. Yeah, they say don't touch it.
Don't mess with it.
It's $100 million.
Gravity. Is this gravity? Equations on the wall.
Faites attention à la file et surtout faites attention à la colonne avant. Ne la touchez surtout pas. Merci.
Don't touch the wire, please. Yeah, no, I see it now.
I got it.
So you can stay this one. Okay? We got two beams there. Okay? Two tubes. And after that, this one is one unit. This is meaning that the two beams are put in the same tube to be able to make the connections. If they stay in different tubes, they will cross but never touch. You understand?
Yeah, but so they're not going in different directions?
Yes, they are going in different directions but in the same tube.
Same tube.
Okay, so this is meaning that on one side of the experiment they are put in the same tube, and on the other side they are separated one more time. And we make this 4 times on the machine because we got 4 experiments on the lid. We get 4 points of collisions. Okay?
You say this is the part where they're separate.
Yeah, they're separated or put in the same tube. Yes. This